All right, last problem on your test review, solving some equations that contain log. So the very first one we have might feel different to you, but hopefully this is solvable with a little bit of common sense. First, these two logs are separated by a subtraction sign. So they can be jammed together into a single log, right? Two logs becomes one log with division. That's law number 2 of our log laws. Now, this may feel weird to you. I didn't do anything with this side because this is not a disguised number. I can't make a nice, pretty number out of that. If that 3 was like a 4 or an 8 or a 16, I could, but that 3 is not friendly. So this might feel weird to you, but notice this. Both sides have log base 2 on them right now. And the only way this equation would equal each other, these sides would equal each other, is if this guy equaled this guy. If they both were the same, then these sides of the equal sign would be identical. So we literally can drop the log 2's right now. We can get rid of them and just figure out, hey, when is x over 7 equal to 3? And if you multiply both sides by 7, you get x equals 21. And hopefully that makes sense. If I put 21 right there, this turns into a 3. This side would be log base 2 of 3 is equal to log base 2 of 3, which hopefully makes sense. But that might be the first time we've seen that type of problem. Let's slide over to B. These two logs are separated by a plus sign, so we can combine these terms here with multiplication. That's law number 1. X times x plus 4, I'm going to go ahead and distribute that. X squared plus 4x, these parentheses here are crucial, and that's equal to 5. 2 logs becomes 1 log. Remember that? These 2 logs becomes 1 log. When you get to this logarithm form, rewrite it in exponent form. 2 to the 5th power is equal to this binomial, x squared plus 4x. Now the word log is gone. This is exponent form. See if this triggers something. 2 to the 5th power is 32. And this 32 I should bring over to this side, setting the equation equal to 0. This gives me something that hopefully factors. So if we dive into the factoring right underneath, we've got an x and an x to get the x squared. 32 is probably going to be an 8 and a 4. And I can generate a 4 with that. If the 8 were positive, the 4 were negative. So my answers are negative 8 and 4. However, always check to make sure your answers don't make the original problem illegal. Remember this location right here? We're staying away from 0 and we're staying away from negatives, and negative 8 is a big no-no actually in both locations. And it only needs to be a no-no in one location in order to cross it out. So negative 8 is bad, but positive 4 is terrific in both locations. So the only answer here is 4. C. All right, same thing that happened up above, which is kind of nice to practice this again. I'm going to move this 2 back to its exponent location. And that's all I'm going to do in this step so you can see it. Moved it back. See, in the previous problem up above, we moved it out front, so we moved it back. These two logs are separated by a plus sign, so 2 logs will become 1 log if you multiply those terms together. So I multiplied the 5 and the x squared. This is the same thing that happened in A. Both sides have a log base 3. So the only way this guy could equal this guy is by setting them equal to each other. 5x squared has to equal 20. Divide both sides by 5 and square root that. Typically, we're used to plus or minus, right? Don't forget plus or minus, and then check to see what type of problem are we working with here. Go back to the original problem. Is 2 allowed to be there? Yes. Is negative 2 allowed to be there? No. Negative 2 can't go there. So the only answer to that original equation is x equals 2. And finally, D. I'm going to do one step right now, move that 2 back to the exponent. And this instead of rewriting this, you notice I came across a different base. So that's not going to be what happened in A and C. This is a disguised number. Do you recognize what number that is? 2 to the what power is equal to 8? Yeah, third power. So that just turns into a 3. I like to call it a disguised number. It's just hidden. It's just there to confuse you. All right, so I did 2 steps in once. I moved that 2 back to the exponent, and I changed that disguised number back to a 3. These 2 logs are separated by a minus sign. 2 logs becomes 1 log. If we combine these terms with division, x squared will go on top of that 5. Now I'm going to rewrite this in exponent form. This 3 to this 3, so 3 to the third power is equal to x squared on top of 5. 3 to the third power is 27. 27 times 5, yikes. 27 times 5, 135. 135 equals x squared. So x equals plus or minus the square root of 135. Yucky. Now, we don't have any directions whether we're supposed to round that to the nearest hundredths. First of all, I can't have a negative number because that tells me no negatives. So it's just the square root of 135. If the directions don't tell you how to write your answer, this is it. It doesn't say round to the nearest hundredths. It did up in the previous 2 problems, but I could leave 135. It could do simplify. We did simplifying 2 months ago. It could say simplify the square root, but it didn't. So I'm going to leave that right there just like that. Okay, that was the review. That was long. I'll see you guys later.